Hello, my name is Jackson Knight, and I'm going to start off our presentation for our Modern Biomedical Tech project, the armrest that we've designed to be used with USF dormitory desks. So just a little background on this. There are many armrests that are being currently provided on the market, and they all address the issues of poor ergonomics at desks. So all these designs, though, they have something in common that we are trying to fix, the clamp that attaches to the desk. So most of the clamps in the market designs are done in a way as a normal clamp where the attaching mechanism goes in from the bottom. However, with USF dormitory desks, there are some desks that have a drawer at the bottom of the desk that stops you from being able to attach a clamp properly. With this project, our goal is to address the ergonomic issues with our armrest, but also make it usable for USF dormitory desks that current armrests would struggle to attach to. So these are just a few examples that you can find through a quick Google search of armrests that are available in the market. Each one is slightly different, but at the end of the day, they all have that clamping mechanism that goes below the desk that will get in the way. And you can see this in this next picture where I have a vice clamp that we actually are using, but not in this way. So as you can see on the left, the clamp is limited to attaching to the desk because of the arm and the screw. And then on the right, you can see that it is not able to attach properly because, again, the clamping mechanism gets in the way, just in a different form. So our problem statement with this project was we need an armrest because everything that's out there does not meet our needs. And this needs to be addressed so that we are not suffering from poor ergonomics here at USF. So ergonomics with what we're currently provided is poor because the desks, they do not come with any sort of support, and the chairs that we're given do not have any sort of armrest built into them. So we have no way to have our arms supported while we're doing work for prolonged periods at the desk on our computers. Current clamps on existing armrests don't work with some of the desks that we are provided, and we need a solution to fix that. Not to mention that many of the current designs on the market are very expensive, upwards of 25 to 30 bucks, which is a little bit much of an ask for some college students. Some of the deliverables we want to hit with this project is obviously make a good ergonomic posture with our armrests because that is what they're intentionally made for. We need a clamping mechanism that is compatible with all dormitory desks, not just the ones that do not have that drawer. And we also want to reduce the cost to keep it below the majority of market prices so that it's affordable and usable for any student that would be in college. So what were our solutions for this? So, like I said before, we want to create a design that was ergonomically friendly. And so we did this by creating the armrest so it sits just above the table, not by too much, but just enough to where it can keep the arm parallel to the ground, but also allow it to sit comfortably on a mouse. To address the clamp, like I said earlier, we're using a vice clamp. However, what we've done with it is we've turned it upside down so that the screw is actually facing upwards. This allows us to maintain the same strength of a normal clamp without sacrificing the maneuverability of the clamp around the desk. And so the one that we use, it's a 2.5-inch vice clamp that you can find at many hardware stores. And while we were initially going to design our own, we settled on this design because it's going to provide us more strength in the most key component for keeping our armrest stable. And finally, to keep the cost low, we are printing the armrest and the base plate out of PETG filament in order to give it a little bit of extra durability and flexibility compared to PLA.
I'm Cody Tedrick, and this is our preliminary design. If you notice on the base plate, there is a circle that will keep the clamp from sliding around. If you notice on the armrest, we have the male peg parts that will connect into the female base plate parts to keep them secured together. Here are our printed designs. The prints came out very well, and the parts look great, and we had no issues with cracking or warping. Here's the assembled design. We have our armrests, our base plate, and the clamp. The inverted clamp method that we used made it so it could be very stable while not interfering with the bottom. And then if you notice the connection points, everything is secured and it does not move or wobble. For our results, the ergonomic position of the arm is much better, and it reduces the pressure on the wrists. And then for the clamp, it worked very well. It did not interrupt any functions of the arm or of the desk. The clamp is the major cost of this, which was $659, and the filaments was $245 for a total cost of $904. So for the applied results, on the top right is correct ergonomic position using the armrest, and then on the bottom shows before, which shows the stress on the wrist. And this is a better ergonomic position, saving us wrist strain, tendinitis, etc. In conclusion, we were able to achieve our goals of a ergonomic armrest while being very cheap. The positioning of the clamp is the main change, and that allows it to be adaptable to any desk, including the dorm desks. It works very well. In the future, we would add a plate to increase stability on the bottom, and we would add cushioning as foam on the top. Special acknowledgements is to Nathan Archambault for helping us 3D print.
All right, so this is just a demonstration of how our armrest works. So the first part is you're going to take the clamp and the base plate, and you're just going to set the base plate wherever you want it on your desk. So after you do that, you're going to set your clamp into this clamp hole, and then you're going to slowly and carefully tighten the clamp until it's tight and it's not really going to move anywhere. And then this base plate also will not move with it. After that, it's as simple as taking your armrest part, sliding it into these holes, getting them to connect, and now the armrest is ready. It's easy to use. It keeps my arm more straight than it would otherwise. If I move my arm back off of the armrest, you can see that naturally it wants to sag more, almost below where the armrest is. But instead, it sits nice, it sits firm. There's not a lot of pressure on my wrist, and I'm able to still have a good range of motion. And that's how our armrest works. So, Jimmy, I just want you to test our product and see, like, what's your honest feedback on what could we do better with it?
Yeah,
So,
of course.
Just put it together and let us know what can we do better.
Let's test this out. Well, I like it. It's nice. It's good support. Keeps my arm upright. I do find when I play games or do homework, I sag a bit. So I do like the extra support. It's nice. If I had any complaints, maybe I'm a bigger guy and my arm weighs a little more, so maybe a tad bit more support on the joint.
Okay.
Make it a bit sturdier. But overall, it's pretty nice. I like it.
Hey, so I'm just going to ask you to do a little demo of our product. Let us know what's good, what's bad, and what can be improved with it.
All right, man, no problem. All right, so I know what problem this is attempting to solve here, so I'm going to start with a control loop here. Yeah, normally like a mouse, it's kind of like you got it on your hand on the desk like this, a little weird, cumbersome. I feel it. I have the same problem. But with an armrest, dude, the mobility on this thing, it's like the axis is now like back here instead of right there at your wrist. One thing I would fix, actually a couple things, would be probably stability on this, and then the coarseness and like sharpness, like the coarseness of the surface and then the sharpness of the edges. Just round them out, flatten it out, and you're good.